right, so we're gonna do another practical application of proportionality, and this is actually really, really cool. How many have ever heard of a scale drawing? You've heard of a scale drawing? I have a thing up there. I usually have a thing up there that says that drawings are not to scale.
Yeah,
But sometimes, like my 8th graders, my 8th grade science class has been making scale models of the solar system. One of my students made a scale model of the solar system, and like the distance.
Is that a basketball?
That is a basketball, and we just hope it doesn't fall
Wait,
on
what's
Andy's
that?
head.
What's that one right there?
That's Saturn.
No, like what's it made out of?
Lumber clay.
It's made out of a foam thing with clay over it. It's kind of heavy. But anyway, so that's another scale model of the solar system. And when you have a scale model, the sizes relative to each other, Ashley and Gideon, are accurate. Okay, so on our scale models of the solar system, some of the kids drawing them, you know, Mercury and Venus are super close to the sun, and Pluto's super far away. Yeah.
I'm in Mr. C's class for scale modeling, so they involve ratios and
It involves ratios a lot. I love that you're already doing it because you're going to be a pro at this because we're doing it today.
Is that the sun?
That's the sun. So the size of the planets is not to scale. I made a scale model of the solar system once to give you an idea of the scale of the solar system. You know, okay, so the sun was about this big.
Did you actually make it that big?
Yeah.
Hold it.
Well, we actually made a fourth of the sun because it was a little bit too big to make the whole sun.
how big are the planets?
And then Jupiter was about that big.
Jupiter.
It was about that big. The sun was this big. Jupiter was about that big. Earth, you know those little silver things that you put on birthday cakes?
Oh,
Bigger
those?
than that. The little silver balls things that you put on birthday cakes, and they kind of hurt your teeth, but we
Like
love them
pearls?
anyway.
Edible pearls.
Like edible pearls, but a
Oh,
little
those-
smaller than an edible pearl, like the silver,
Yeah.
like a little edible ballberry. That was the Earth and Venus. Mercury and Pluto, you know the little teeny tiny sprinkles that you put on birthday cakes?
Yeah.
That was Mercury and Pluto. At that scale, so we didn't do the scale to distance.
The moon.
I didn't make the moon.
That was probably.
It would have been too small. Like you wouldn't even be able to see it.
Wait, I thought-
At that scale, Pluto would have been 2 miles away from the sun.
Wait, the moon is actually.
The moon is a lot smaller. If we finish everything today, I have a cool video on the scale model of the solar system that I show my science class that I can show you guys. But we need to get moving on our scale stuff. Yes.
What if you did it to scale in size and you had the sun next to that giant sun thing? I
Right. Well.
forgot the name of the sun.
Oh, like a
Big.
Betelgeuse. Betelgeuse is a giant star.
I mean like this sun. Like
Spelled
there's
differently.
multiple suns.
There's
And there's,
multiple
like,
stars. There's only one
one
sun.
that is.
But we're not going to squirrel off into that because we could go way off into that. Yeah, the sun is only a medium-ish small star. The sun is not a very large
Yeah,
star.
the sun is just like.
It's kind of small compared to other stars.
Right, it's medium-ish small.
Yeah,
It's not the
yeah,
smallest.
stars are
But
big.
it's not even medium. It's like medium-ish small.
Yeah.
Okay.
Which
So
means Earth is
Extra small.
scale models are really useful. Can I show you how far away Pluto is from the sun? Can I show you that? Okay, Forrest and Marty, if you guys don't stop talking, I will have to separate you. Okay, because this is becoming like a daily thing. All right.
You could draw up on the board.
So I can't show you. I don't have a spaceship, but even if I did have a spaceship, Pluto's so far away, like we can't even see how far away these things are. But when we have a scale model, it brings it to a size. How many like that one? That one is pretty much to scale, and you can see how much farther away Pluto is than Mercury.
Have
okay?
we visited Pluto
We
yet?
have not. There has been a satellite that's gone past Pluto and taken awesome pictures of Pluto, but no humans have visited Pluto. No humans have gone anywhere past the moon. We haven't even visited Mars. We have little robots on Mars, but we don't have people.
Why don't we just put a person on
Because it takes a long time to get there, and like it would take like 2 years to fly there.
Yeah, like
Who
the
cares?
moon takes a long time to get there.
Well, it takes like 15 minutes. It's not too bad.
It's not too far.
It's not too bad when you're going that fast. But Mars is a lot farther away.
It's
like
two.
So, let's talk about scale. Now, the scale model of the solar system involves some pretty intense math because the distances are big and the numbers are big. But we're going to have smaller scale. If I'm going to have a rectangle actually, not a square. If I have a square here, or a rectangle here, and this is 1 inch, and this is 3 inches, and this is 1 inch, and this is 3 inches, I can scale it up, right? Like if you have a phone and you go like this, you're scaling it up, and everything stays proportional. It just gets bigger. So now this is 3 inches, this is 9 inches, this is 3 inches, and
Wait,
this
how
is
come
9
the
inches.
sides are 3 inches?
What was that?
How come like
Because it's bigger.
Oh!
So here's the question. Are the sides still proportional?
Yes.
How do I know?
Because you
Because
just
they-
get you multiplied all the 4 numbers by 3.
I multiply, it's my constant of proportionality.
Yeah.
What's my constant of proportionality?
3.
3. So 1 times 3 is 3. 3 times 3 is 9. 1 times 3 is 3. 3 times 3 is 9. Sometimes when you're scaling things up, you make mistakes. Like
Yeah.
what if there's one scale up, but what if I do this?
Like,
A slightly smaller scale up.
that's
Well, that's wrong.
Why is it wrong?
Because it's supposed to be 6. Because you're multiplying everything by 3.
Well, no,
Well,
it's
it-
not scaled as big.
That time it's multiplied
This
by
time
2.
the constant of proportionality should be 2.
2. Yeah.
1 times 2 is 2. 3 times 2 is
5. 6.
6. Did I scale it up right?
No.
Is this proportional?
No.
No. Is it an
Or you
accurate
could also-
scale drawing?
You could
No.
also make a mistake by just like adding, like,
I could have made a mistake by adding them instead, but then I would have done it wrong and it would be wrong, right?
Yeah.
So that happens. It happens a lot, actually, when people are doing things to scale. That they'll do one part to scale, but maybe not the other part to scale, okay? Like our scale model of the solar system, the distances are to scale. Are the planet sizes to scale?
No.
No, the planet sizes are not to
And
scale.
Earth is teensy.
Well, Earth is small compared to Jupiter, but on that scale, those planets, we wouldn't even be able to see them. They'd be microscopic. Okay? So,
is that pin where we are on the Earth?
the pin, that's the moon. The moon is sticking out of the Earth.
Why is the moon yellow?
Because the moon is kind of yellowy colored if you look at it. Right?
I
So,
think it is by
Do we always go bigger with scale models?
No.
No, sometimes when I'm designing a quilt, so I'm designing a quilt, right? And my quilt is gonna cover my whole bed.
Is it a square?
Quilts are often squares. We're gonna pretend that that's a square, okay? And let's say that my quilt is 8 feet by 8 feet. And I'm gonna have a bunch of blocks. I'm gonna have 8 blocks by 8 blocks. Well, when I design what my block looks like, can I really make it that big? Can I design, if I design my quilt layout, can I really make it that big?
Yeah.
Am I gonna have a piece of paper that's 8 feet by 8 feet?
That's
No, it can be like this big of a paper.
It could be, could this be my quilt design?
Yes.
Yes. So this is my quilt design, and I can design it, and I can divide this into 8 and into 8. So then I need to figure out, okay, so this was this an enlargement or was this a reduction?
Reduction.
How do you know?
You're dividing it up.
Because reductions get smaller and enlargements gets bigger. Large, you guys know what large means? It's an enlargement, means it made it bigger. And reduction,
Reduce.
it reduces. Thank you for that, Hannah. Yes, Ashley.
Isn't 8 feet like from the floor to the ceiling?
8 feet is from the floor to the ceiling. But that's about Actually, I think these are 9-foot ceilings here.
That's a big.
So it's like
Go just a
almost.
little shorter then.
It's a little shorter than that.
Like from the top to.
It's up to the top of the whiteboard.
That's a really,
No,
really big.
No,
higher than
top
the
of the
whiteboard,
whiteboard's-
probably up to like the.
It's about up to the top of my clock. Which when you think about it, like I'm married, I have a double-sized bed. 8 feet by 8 feet is not an unreasonable size for a quilt. Actually, it's big,
Really
but
big.
it's not
That's a good
that
size.
unreasonable for how big my bed is, right? So okay, so what is the scale here?
Eight.
I'm going to get a ruler. Hi. I'm gonna get a ruler because, and I didn't even try to make this awesome, so it's probably gonna be kind of ugly.
That's okay.
So
though.
this whole thing is 10 inches.
Wow.
That's it.
World's biggest quilt ever.
10 inches is gonna be proportional to 8 feet.
Wow.
Okay? You know what would have been better? Is if I had made it 8 inches, but I didn't.
The entire whiteboard.
8 inches?
If I made it 8 inches,
Wait, how?
but I didn't.
What if you made it the entire whiteboard?
That would be really big, but I didn't. Okay.
That'd be like
So 1 inch equals how many feet?
Well,
0.8 feet. How did you figure that out so fast?
I knew that if we needed to figure out how many 10s were 8, so I divided 10 divided by 8.
It would be 8 divided by 10. So you need to have a scale, and your scale is always going to be 1 something equals a certain amount of something else. Okay? So here we have 1 inch equals 0.8 feet. Now usually when you make a scale, you want to make it kind of nice. That's why I said I should have made this so it was 8 inches, then I would have 1 inch equals 1 foot.
Or 2 inches.
Or 2 inches.
6 inches.
Wait, so
Wait, no.
1
No, 4.
inch equals 8 inches.
1 inch equals 0.8 feet. Yeah, which would be 8 inches.
Yeah.
1 inch on my scale.
Wait.
1 inch on here represents, no, 0.8
It's
feet.
not.
When I
It's
was
not
making
pretty
my
because it's not
model,
metric.
I had a scale of 1 to 30.
Okay, when Austin did his model, he had a scale of 1 to 30. So 1 inch equals 30 inches on his model.
That's big.
No, that's small.
Well, the 30 inches is big, okay? 1 inch equals 30 inches. Sometimes your units get shifty. You can have 1 inch equals 3 feet. Is that okay?
No.
Yeah,
Yeah.
it is.
Yeah.
But you just have to keep track of your units. Austin did a generic 1 to 30 so that everything would stay in inches or everything would be in centimeters. But you can switch units. You just have to pay attention, okay? Yes?
I would take the number and like do all this stuff, but then I would end up getting feet.
Yeah, if you divide it by 12, then you get feet. Okay, so let's say we have Austin's scale of 1 to 30. Okay, let's use Austin's scale of 1 to 30. If I draw a cube, so Austin's gonna build a cube.
Whoa.
Probably not really, but we're gonna pretend that Austin's gonna build a cube. And this cube is 2 inches on a side, and 2 inches on a side, and 2 inches on a side. Because it's a cube, so all of its inches are the same. How big is Austin gonna build this thing in real life? Zach, and how do we figure it out?
60 inches on each side.
How did you figure that out?
Because the 1 inch, it's 2 inches.
1 to 30.
1 times 2 is 2. So, and 30 times 2 is 60.
2 to 60.
60 inches on
Okay.
both sides.
Whenever you make a scale, you always want to make it, like if I'm designing a quilt block, I have graph paper that's 1/4 of an inch. I'll often make it so that 1/4 of an inch equals 1 inch on my quilt. What would the scale be? 1 to what?
1/4.
1 to 4.
Wait.
Because 1/4 times 4 equals 1, so that's a 1 to 4 scale when I'm using my 1/4 inch, with my 1/4 inch graph paper. I make scale drawings actually a lot in my real life when I'm designing quilts. When architects design buildings, can you draw the plans for a building that are the same size as the building?
No, you would have to need
Well,
a
you
very big
can.
printer.
You can, but should you?
No.
I mean, they don't make printers. Mr. Beck has giant printers in his room. Are they even big enough to build design? No, they're not even big enough.
Depends on how big the building is.
Maybe if you're making a doghouse
Or out.
Dollhouse.
or an outhouse, but even then, the outhouse is 8 feet tall.
Make
We're
it
just
8
gonna
inches.
say you're making a tiny little doll.
If you're making a tiny little dollhouse, oh, if you're making a tiny, let's say you make miniature things.
Light digger.
Can you help me understand why you think that that was okay to do in my class? Can you? Then is it? All right, let's say I'm making something in miniature. People make things in miniature all the time, okay? Let's say I'm making a miniature quilt block. Is that a thing?
Yeah.
These people, they make these quilts with little 1/4 inch things, okay? So I'm making a miniature quilt, and I want my finished quilt to be 4 inches by 4 inches, and it's gonna have little teeny tiny papers, okay? Can I make my plans bigger than my miniature? Yes, I can make my plans really big so that I have like all the exciting things going on. Okay, and so this is 8 inches and this is 4 inches, and I make it big so that you can see how big it is, right? What's my scale? 1 to what?
4.
1/4 or 1/2. How do we get from 8 to 4? You half it. Or I could say there's a 1 to 2 going this way, or 1 to 1/2 going that way, okay? But you half it. So, 8 to 4, I have a bigger scale here, and then it gets scaled down, okay? Usually, you're not gonna have a scale of 1/2, but like, let's say I wanted to make a scale model of an atom, okay? Can I make a scale model of an atom?
Yeah, you just enlarging it.
You just enlarging it. If I make a scale model of an atom, you know what I have to do though? If I put a couple of golf balls in the middle of a football field, the electrons are in the bleachers.
What are electrons?
They're the things that go around the nucleus. I will teach you all about that. The nucleus has protons and neutrons, and then there's electrons flying around the outside, and we usually draw them like this. This is helium, so it's going to have 4. So we usually draw them like this, but those electrons, this is not to scale. Those electrons are not that close, and they're not that big compared to the nucleus. The protons and neutrons are huge compared to the electrons, and the electrons are crazy far away. This is not to scale. Those electrons are not how as close as they really would be, okay? So, can I really make a drawing of an atom? No, but can I make a scale drawing of an atom?
Yeah.
Yes. Would my scale be huge?
Yeah.
Yeah, because my electrons are super far away, and in real life, the electrons are super, I mean, it's teeny, teeny, tiny, but it's still far away relative to it. Okay, let's do some more practice with the regular ones, and then I think you guys are going to be ready to go on your assignment. What if I have I'm making a brochure, okay? For a picture, for an art gallery. And I want to draw a picture of this amazing work of art. Okay? Right? You guys wish you could draw this stuff.
Yeah.
All right, and this is 2 feet by 3 feet, and my drawing is going to be 4 inches by what? First of all, what do we need to figure out, McKinley?
What you have to multiply.
We have to figure out what we have to multiply by, okay?
2.
Do we multiply by 2? Okay,
Yeah, because 2 times 2 is 4.
2 times 2 is 4, so it would be 3 times 2. Now we're going from feet to inches, is that okay? Can we mix units like that? Yeah, we can. We could totally mix units like that. What's our scale going to be? 1 foot to what? 1 foot equals what?
2 inches.
2 inches. Is that an okay scale?
Yeah.
Yeah, totally it is. So if 1 foot is 2 inches, that's 2 feet, that's 4 inches, so that's 3 feet. So what's that one gonna be?
6 inches.
How did you find that, Zach?
Because 3 times 2 is 6.
Because 3 times 2 is 6. So 3 feet is gonna be 6 inches. How is everybody feeling? Hannah, how are you feeling?
Good.
Forrest, how are you feeling?
Okay.
Okay, do you want me to do one more?
Sure.
Should we do one from your assignment?
Yes.
Yeah.
The one with the fancy lady picture.
Oh, that one's easy. That one just asks you, does it get bigger or smaller?
No, not that one. No.
Yeah, not that one. Let's do number 7 with the volleyballs.
Volleyball.
Number 6.
I like volleyballs. I like
Volleyballs are enjoyable.
Volleyball.
Except when they're coming at your head. I have problems with that.
You step to the side and hit him.
You don't step to the side. You actually
Or
get
you
under
step
it and hit it. Okay. First of all, I need to do something. What do I need to do? Do you guys see what I need to do?
No.
Can I compare those the way they are now?
Yes. No. That's a small volleyball.
Remember it's the drawing of the ball. It's the actual volleyball is 24 centimeters. The scale drawing is 6 centimeters. We're drawing a volleyball in our brochure about fun sports that we're going to play.
Wait, but that's only half of the scale drawn volleyball.
What do we need to do?
You need to finish it.
We need to finish it. That's only the radius. We need the diameter. Austin, what do I do here?
Times it by 2.
Times it by 2. So what's the full diameter?
12 inches.
12
centimeters.
12 centimeters.
Not inches.
I've got to tell you guys, one of the biggest mistakes that I see on students is when they forget that a radius is not the same as a diameter. So make sure you watch that, okay? You'll know how to do it and everything will be great. And then you're like, oh crap, I forgot that a radius is not a diameter. Okay, what's my scale factor? If I'm going from this one to this one, what's my scale factor?
1 to 2.
How did I get from 24 to 12?
You divide by 2.
2
I divided by 2, so 1 to what?
2.
Half.
1 to a half. What if I'm going from that one to that one? What's my scale factor?
1 to 2.
1 to 2. Okay, so you have to remember which one's the actual one and which one's the drawing.
So we're doing the 1 to half.
1 to a half. Yep.
And the scale
If you
factor
put 1 to 2,
one-
I won't mark it wrong.
And the scale factor is 1 to 1/2.
Mm-hmm. All right, I think we're good. We feeling good first? You feeling better?
Yeah.
How do you feel over there?
Good.
Good? Good.
Good game. Good game.
So we can